Okay, welcome back. Today we're going to be continuing some more GCSE level trigonometry. We'll start off with a quick review from the last video. So, in this question here, we have to solve for the angle x. Okay? So, because we're solving for an angle, we're going to use SOHCAHTOA. And when we're looking at this, what trigonometric function do we think we're going to use? Well, it's going to be tan, right? Because we've got the opposite to the angle and the adjacent to the angle. So we're going to say that tan of x is equal to the opposite over the adjacent. It's going to be equal to 8/4. So to get tan, or x by itself, we take the inverse tan of both sides. So I'm going to say x is equal to tan, the inverse tan, of 8/4. So on our calculator, x is going to be equal to the inverse tan of 8/4, which is 63.434, ... because it keeps going on, you see. And then rounding that, no, sorry, x is equal to 63.4 degrees. That's our first question. Now, I'm going to give you an opportunity to solve this one. The video will play in 3, 2, 1. So, when I'm looking at this, I'm thinking, right, okay, it's a little bit tricky, but it's a right angle triangle, so I know I'm going to be using SOHCAHTOA or Pythagoras. Again, because we've been given an angle, I'm thinking SOHCAHTOA. So we're going to start with, what are we trying to find? Well, if we've got SOHCAHTOA, well, we've got an angle, and we've got this side adjacent to the angle, so I know I'm going to be using an adjacent side and an adjacent side. So we know we're not going to be using sine now, because we don't have an opposite. We're trying to find the hypotenuse. So what are we trying to find? Well, we're trying to find the hypotenuse, and the hypotenuse isn't in this one, so we're not going to be using tan. So looking for cos. So I'm going to say that cos of 60 is equal to the adjacent over the hypotenuse. So it's going to be 3/x. Yeah? And then to find x, well, we can just times, well, okay, well, we'll do this a long way. So we can say x times cos 60 is equal to 3. And then x is equal to 3/cos 60, which is equal to 6. I'll just show you that on the calculator quickly. 3 divided by cos of 60 is 6. Great. So that is our review from the last video. Now today I'm going to introduce you to 2 new rules that you don't need to memorize because they should be on your formula sheet. Okay, so first of all, you've got the sine rule, which says a over sine A is equal to b over sine B, which is equal to c over sine C. Okay, so the side divided by the sine of the angle is equal all around the triangle. And the other formula is the cosine formula, which is a squared is equal to b squared plus c squared. And where do we see this? This is quite similar to Pythagoras, minus 2bc cosine A. Okay, that one's quite a long one. That one you don't need to memorize as well. That's on the formula sheet. So we have the sine rule and the cosine rule. Okay, so now you may look at this, okay, what's capital A and what's lowercase a? Well, I'll start for you. If I had to draw a triangle that isn't a right angle triangle. These ones only work in non-right angle triangles. Well, not only work, but they're used in non-right angle triangles because you can't use SOHCAHTOA when there's no right angle, okay? So if I were to call this side C, this side A, and this side B, that angle, that's going to be C, that's going to be capital A, and that's going to be capital B, capital, okay? And the side opposite to it, that's going to be the lowercase letter. So that's going to be A, that's going to be lowercase b, and that's going to be lowercase c, like that. Okay, so we're going to start with a little question. Okay, if I have my triangle like that, see if I can sort this out. Okay, and I have C, I have A, and I have B. If this angle there is 60 degrees, and that angle there is 42 degrees, and that length there is 30 centimeters, sorry, what is this length A? Well, we can use our formula. So we write it out, as always. A over sine A is equal to B over sine B. Now, we don't need to write the last part of it because we're not worried about angle C. So, I'm going to say that A over sine 60 is equal to 30 over sine 42. And then we're just going to rearrange to find A. So we can say A is equal to sine 60 times 30 over sine 42. And, oh, we're running out of space here. So A is equal to, that on the calculator comes out to sine 60 times 30 divided by sine 42. Well, that comes out to 38.827. Dot, 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 because that keeps going on. And then we just round that. That becomes A is equal to 38.8 centimeters. Nice and easy. Okay. So, I am going to now show you an example with the cosine rule. Okay. So if I have another non-right angle triangle, like that, if I had this length, or this angle there as C, this angle there, A, and this angle there, B, well, I'm going to call that side length 5, that length A, and this length C. Okay? And that angle there is going to be 30. So the cosine rule works by only looking at it, is the angle must have no lengths either side of it. Okay? So you couldn't work it out if you had this length and you're trying to find this length. You can only have it if it goes like side, angle, side, like that. Okay, so I'm going to start. Write down our formula. A squared is equal to b squared plus c squared minus 2bc cosine A. Okay, so, well, we're trying to find a squared. So a squared is equal to 5 squared plus 10 squared minus 2 lots of 5 times 10 times cosine 30, because that's our angle A. So A squared is equal to, well, 5 squared is 25, 10 squared is 100. 125 minus 5 times 10 is 50, times 2 is 100. minus 100 times cosine 30. So a squared is equal to 125 minus 100 times cosine 30. Well, that's 38.397 dot 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 dot. So a, then take the square root of both sides. Oh, yeah. So a is then going to be equal to 6.1965. So a is then 6.20 centimeters. Okay, once we round to three significant figures. So I'll do one more question, just to really get this into you. So if I have my triangle, this is going to be an isosceles triangle. So that length there is 5, that length there is 5. If I'm looking to find that angle there, and I've been given this angle 67, what can I do? Well, not an awful lot to start with. We can have a look at our isosceles triangle. We know that an isosceles triangle is the same as two right angle triangles like this, right? So if that length there is 5 and that length there is 5, and that angle is 67, well, we can work out this height, can't we? Call that height x there, okay? So, well, we can use our SOHCAHTOA. And if we've been given an angle and we've got the hypotenuse and we need to find the opposite to it, it's going to be sine, right? So I can say sine 67 is equal to x over 5. So x is equal to 5 lots of sine 67. 5 lots of sine 67. So x is equal to 4.6025. 4.60 centimeters. Okay. And then once we found, oh, sorry, I've done that all wrong. You don't even need to do that. If you find in this angle here, we know about isosceles triangles is that these two base angles are the same. So if that's basically the same as having that as 67, and that is 67, and that is theta. So angles in a triangle add up to 180 minus 2 lots of 67. Well, that's going to be equal to 46. 46. I've wildly overcomplicated that. So now we can use our cosine rule because we've got a side, an angle, and a side. So if we say we're looking for this length here, we'll call that A. So we can say a squared is equal to 5 squared plus 5 squared minus 2 lots of 5 times 5 times cosine of 46. Right? Because that's our formula, a squared equals b squared plus c squared minus 2bc cosine a. So let's solve that. A squared is equal to, well, 25 plus 25, 50, minus 5 times 5 is 25, times 2, 50. 50 cosine 46. A squared is equal to 50 minus 50 times cosine 46. Well, a squared is going to be 15.267. So a is going to be 3.907, which is then going to be equal to 3.91 centimeters. And that's that question solved as well. So that's a quick introduction to the cosine rule. Problem sorted. Thank you very much for watching.